Microcontroller.com. We're at the Embedded Systems Conference, or as it's called here, Design East, and we have John Day is going to introduce himself and talk about today's demo. How are you, John?
Hi, Bill. I'm doing great. How are you?
Wonderful.
So today I'd like to show you the MCP39xx energy monitoring analog front end. It's used in a pretty interesting application here, where we effectively have the MCP39xx. That analog front end has a programmable gain amplifier inside of it and a up to 24-bit delta sigma ADC. And what that allows us to do is directly measure line current and line voltage with an extremely high degree of accuracy with no external components other than a current sense resistor.
What's the accuracy on AFE?
The accuracy on the AFE, in order to make power grade specs, you have to have accuracy of roughly about 0.5% total, which is quite difficult when you consider, harmonic distortion and different AC waveforms.
And what's the part number?
The part number we're using here is an MCP3901, and there's different versions. There's 3905, a little bit lower end version. We're using a 3901. It's 24 bits in this particular case. And that device has an SPI interface on it. We, in this particular demo, have a PIC32, which is running a TCP/IP stack, and that, through Wi-Fi, is creating a Wi-Fi hotspot where we can then display the power consumption of a typical device, the amount of energy that's used, in real time. So we have, from a block diagram point of view, the AFE, which is connected to a current sense resistor in series with the load, and then it's also measuring the voltage, and then the PIC32 is continually monitoring or polling that, grabbing that data, calculating the real power, VA, and then it's updating its web page on an instantaneous basis so you can look at that power change. So let's demonstrate that. So we have this analog front end, and it's going to measure. If we take a look at this iPad here, this is actually connected to the web server provided by the PIC32 connected to our AFE. And I'll turn this inductive cooktop on. Now you can see that the current consumption, we're currently at roughly a power level 2. We can see our current is right now 3.401 amps at 201 volts, so we're basically 390 VA. And then we can start raising that power. So I've just raised the power now to power level 6, and now we can see we're drawing basically just under 1,500 watts.
And the AFE is giving us that accuracy.
And the AFE is giving us that accuracy. And so that AFE is a pretty simple component. You literally connect it to your current sense resistor, connect it to your voltage, and bang, you have a very, very high accuracy, real-time power measurement. So it's a good part.